Welcome back to Proof of DeSci, the podcast where we explore the future of science at the intersection of crypto, biotech, and community. And today, apart from Morgan and Albert from ValleyDAO, we're also joined by Jake Wintermute, a synthetic biologist, science communicator, and former developer evangelist at Ginkgo Bioworks. With a PhD from Harvard and over a decade of academic experience in Paris, Jake has dedicated his career to making biotech more accessible, from low-cost drug discovery to teaching thousands through his Synthetic Biology 1 course. And in this conversation, we're going to dive into the big themes shaping DeSci, how lab automation could transform decentralized science, why climate science needs some form of new narrative to capture additional attention and funding, and yes, even memes, meme coins, how humor, culture, and communication can help scientists with the attention war online.
Especially memes.
And this episode is equal parts serious and fun, just like DeSci itself. So let's get into it. I have 3 sections of this Twitter Spaces, of this Twitter podcast. And the first one, we actually want to talk a little bit more about the connection between lab automation and DeSci. So in principle, automated labs like Ginkgo Foundry could be a great enabling layer for DeSci. In one possible future world, projects that are created and funded on DeSci platforms can be executed remotely in automated labs, giving DeSci founders just a little bit more direct control over what they fund and build. Jake, first question to you. What would it take for a DeSci project to be executable in an automated foundry?
Yeah, that's right. This is like what's on my mind the most lately, is this connection between lab automation and DeSci. And I think just to kind of level set, I see a lot of familiar faces in the audience, and I think there's a lot of people who are already kind of expert in this space. But I want to just kind of set the expectations here for this conversation. There is, it seems, a natural connection between lab automation and foundry biotechnology and the goals and the structure of the DeSci community. So on the one hand, you've got DeSci, and this is a place for funding. It's a place for developing ideas. It's a fully decentralized space that exists only in the world of bits. So it's a purely digital community where the ideas can bubble to the top. And this works for biology to the extent that you can code your ideas in DNA, or you can talk through your ideas with an AI model, or to the extent that biology can be well expressed in purely digital terms, you can go pretty far in terms of developing a biotech idea in the context of a fully DeSci space. Then on the other hand, you have foundries. And so Ginkgo Bioworks, where I worked until a couple of months ago, is probably the flagship example of this, but there are others out there. And there are other people who are working on this dream of an automated lab, or a cloud lab, it's sometimes called. This is a physical space that is going to execute on the atom layer of building with biotech. And so the model of something like a cloud lab, or the sort of ideal case or the dream case of a foundry for biology, is this is a place where you can upload a biological design, or so maybe it's a DNA sequence is the thing that you're uploading. Maybe what you're uploading looks more like an experimental protocol, a series of steps. Maybe what you're uploading is more like an abstract idea. So I want a microbe that produces a particular chemical, or I want a protein that activates a particular receptor, but you don't specify it all the way down to the level of an individual DNA sequence. But you upload something about this design to a foundry, and then the foundry is the physical layer that can execute on that design. And so this is my entry to DeSci. I've always been sort of interested in decentralizing and democratizing science, making it available to more people. But this is the challenge and the provocation of the interplay between foundries and DeSci. What is it going to take to get us to a place where the people of ValleyDAO can create a design and then, totally hands-free while they're at the beach working on their laptop, upload it to a foundry, and then the foundry is going to be the execution layer that makes that dream a reality. So that's a provocation. That's where we want to get.
That was a great start of the conversation, Jake. And just for your information, us founders at ValleyDAO, we're still chilling at the beach. Our foundries are, PhDs and postdocs. So you can still chill at the beach as a DeSci founder. So those who got worried there, don't be. But Jake, I wanted to ask you a follow up on that. Perhaps what is the, from your perspective, having worked with Ginkgo and to the degree that you can speak about these things, what level of maturation is the automation technology at right now? Just 5 years ago, people were talking about a range of difficulties of automating lab work, and foundries were just merely a little bit of a pipe dream. There was a lot of startups in SF popping up, saying that they were going to do everything. You would basically just upload a PDF with your spec sheet. It would be just a spec sheet. And then, 3-4 weeks later, you would have the result, and they would just do anything for you. And nothing really came out of that. What has changed since, and how is Ginkgo currently integrating all of these different, I can imagine, components that goes into creating this long pipeline?
Yeah, I think so. It's a challenging question. I mean, I think to kind of cut to the chase, the clear, the straightforward, simplest problem is that it's still too expensive. The biology is still too hard to engineer, and so a typical deal for a bioengineering project at a place like Ginkgo would run into the millions of dollars, and that's sort of still outside the budget of a typical DeSci project. So that's the big picture, right? Is we've got to get the execution layer cheaper. I think that there's a few other factors that go into it when you're talking about what does it look like to build a DeSci execution layer. So I think the things that are holding us back its education is key. So there needs to be some kind of an education layer. There needs to be some kind of a trust layer when you're executing. There needs to be the actual capabilities there. And then I think there's some cultural barriers that are also holding us back in terms of getting more of these DeSci projects into automated labs. So at least in principle, working in a foundry, we have the sort of educational challenges, or just the fact that biotech requires a lot of expertise to execute on, that's solved in a foundry. You can get a bunch of PhD level scientists. You can get the equipment that they need in their hands. Because it's a centralized facility, it plays really nicely with national governments and regulators. So it's a sort of single point of regulation. It's a place where you can be compliant with whatever regulations you might have around executing biotech. And so a foundry style of execution is very friendly in that sense. But I think the primary problems are around culture and cost. And particularly, I think something that we're seeing is that this sort of economics of scale for foundry projects only work well, or they work the best in certain domains. So for example, if you want to do antibody engineering is something that can be automated and scaled pretty effectively. And so I think that's a space where we're likely to see more projects. It's something where you can there's a market, right? There's a market for big biopharma customers and being able to offer that capability. And then that's going to make the capability cheaper, and that's going to make it accessible to more people. But then there's a kind of a long tail problem in terms of executing on biotechnology, and that's a space that we haven't solved. So if you want to do something, really innovative, really quirky, really unique, the economics of getting that into a standardized, automated format that can be executed without a lot of really expensive human labor costs, that's a problem that we haven't solved yet.
It works the best for any type of workflow that is quite standardized, as you said with the antibodies example there.
Yeah, this is the space. This is the type of project that I like the best in terms of this sort of full dream version of automated execution. Antibodies are very standardized. They're all They're all relatively easy to handle. There's a relatively small suite of experiments. And then there's a reasonably large space of antibody drugs that you could go after. So therefore, I'm pretty optimistic that our capabilities for, like AI generated protein binders, that's something that's going to get cheaper pretty quickly.
Can I play devil's advocate here? and I just wanted to bring up you mentioned like some of the limitations of cloud labs, and it feels like some of those might be better addressed by like DIY biolabs. And I wanted to get your take on it, Jake, and everybody else here. Like, where do you see DIY bio taking off? And, we're not just talking people doing GFP experiments in their back gardens, but like, what will it take for people to get actually sophisticated science being done in a decentralized way in smaller, more distributed facilities at lower cost than maybe a cloud lab project would cost?
Yeah, I sort of love this possibility, and I've always been a DIY bio fan. Like, I think it's in my blood. So this is something that I've been engaged with a lot in my career. So when I was an academic in Paris, for example, I was involved in some DIY biotype projects. I worked on a thing called DNA Detective. And this was it used like a rolling circle PCR amplification to detect GMOs in food. And so the idea was that this was a capability that we could put in people's hands if they were GMO skeptical, that would let them detect GMOs in their food. But of course, then as part of the bargain, they have to actually handle, DIY DNA amplification technology and build their own DNA biosensor, with the hypothesis that maybe by building that's going to, change their perspective. It's going to change their perspective.
I was just about to say, why would you put such a tool in the hands of the skeptics? It's a very counter.
I love it because I love it. I'm an agent of chaos. I'm an agent of chaos.
Very nice. Respect.
So I also worked really closely with the iGEM team for many years in Paris. And so coming back to the question of what is it going to take to make DIY bio work, iGEM is a place where we can learn some lessons there, because I think it's the closest example of a sort of scalable, distributed, reasonably low cost system that can execute across the long tail, right? Like, there's a lot of weird stuff happening in iGEM. So like, if I wanted to break down like what are the lessons of iGEM, right, for scaling up DIY bio, I think I can break it down into sort of four different properties, four different ingredients that you need to have a successful, scalable approach to executing in biotech.
Mm-hmm.
There's an education layer, there's a trust layer, there's an execution layer, and there's a culture layer. So education, in the sense that it requires some expertise to be able to build these systems effectively. iGEM solves that problem by embedding students in conventional academic degree programs, right? Like, that's where iGEM students learn to execute, and it works pretty well. It works pretty well, if I'm being honest, right? Like, it really challenges the students. It really pushes the limits of what they are capable of, given the amount of instruction that they've received, right? And so, like, if you're thinking about DIY biolabs and what it's going to take to scale DIY biolabs, I think you can look at the education layer of iGEM and get at least some sense for the kind of capabilities that you need to put into people's hands in order to have them be working on projects remotely.
Yeah.
There's a trust layer. There's a trust layer that you need, right? And so that basically there's a sort of regulatory safety. You have to kind of play nice with the authorities in order to make something like this work. iGEM solves this by embedding with mainstream institutions that already have a lot of trust. So that works pretty well, although it does kind of narrow the scope of what's possible. Like, you can't really start an iGEM team in your garage. You can't, you do have kind of, it pulls people back into the kind of mainstream biopharma culture. So it does limit iGEM that way, but it activates iGEM on the other side, because it means that iGEM they have a lot of trust, and they're not having to play whack-a-mole or something with regulators trying to shut them down. Then there's the execution layer, the equipment that you need to be able to do one of these DIY bio projects. Like I looked this up a couple of years ago. Typical iGEM team budget is maybe around 50 grand, which is like, that's DeSciable amount of money.
Yeah, it's quite a lot of money considering the number of teams there are.
It's quite a lot of money. Yeah, it's quite a lot of money. I mean, and it ain't 2 million, right? It ain't. It's a hell of a lot cheaper than 2 million.
Yeah, I would though say that a lot of this money is spent on just figuring out how the protocols work, how the different equipment work, and just getting the first protocol to actually work in your hands. So
cold.
Yeah, it's not that, but it's just like so much of this money actually goes to essentially nothing. Like iGEM would have been better if it was like a 2-year program where 1 year you're just like figuring things out and you because every team member essentially need to learn how to work in the lab. Like they have some training, but they haven't fully gotten the feeling of the wet lab work. And so yeah, it's like 50K. It's not that much, but realistically, I would say it's more around 150K if you want to like create a project that has some sort of substance to it. But then a lot of teams get away with 50K and they create something interesting, but the majority unfortunately don't. But still, I totally agree with you. Like iGEM it's quite a well-functioning representation of a distributed lab network in SynBio, and we just don't have anything else comparable to it right now.
Yeah, there's lessons to learn. I mean, like what you say, you're absolutely right. Like there is this, you could call it a cold start problem. I've been lately thinking about it in terms of the culture layer of executing in DeSci, and so here the challenge that iGEM poses, or something that's holding it back in terms of being able to like really deliver jaw-dropping projects regularly, is the fact that it's a one-off experience for a lot of students. And then when it's done, students are drawn back into the world of academia and the world of conventional mainstream science. And so in my mind, I call this a culture problem in the sense that the students of iGEM, like they don't see themselves as entrepreneurs who are, building DeSci projects and that their career is in DeSci. They see themselves as academics who are having academic careers, and their iGEM experience is a sort of a short-term internship that is letting them build their skills. And so therefore they look away. They get absorbed back into the academic world. And so this is a place where DeSci has some leverage in the sense that I don't think we're that far away from DeSci standing itself up as a genuine alternative career path for a young person. Like if you could place where a typical iGEM student would say, no, I don't actually want to do a PhD. Like that's not my life goal, is to do a PhD after this. I want to keep going, and the DeSci ecosystem is going to be there to fund me, support me. It's going to provide my professional network, and like I see myself as growing into the culture of the DeSci world for over the course of a decades-long career. Like that would be transformative, because then you could have these sort of iGEM style projects that didn't suffer from this limitation of the limited time frame and the cold start problem.
Yeah, yeah. It's one place that all of these graduate students, if they want to pursue something in DeSci, the one thing that DeSci has to start being able to provide is a physical space for them where they can actually do some experimentation. And one person who is doing a really good job of that right now is Elliot Roth, actually, with the Frontier Tower project that they have in SF. Basically, some multimillionaire bought up this whole building, and each floor has some sort of theme, and they have their own floor there where they focus a lot on bioengineering. And we've actually discussed a little bit back and forth of how to fund like these smaller type of projects. I know I shared it with you, Jake, the other day when we had a call about this sort of like community, and there's like a subscription model where you can subscribe like everything from like $1 per month to how much you want per month. And then you get voting power. And then every month, that community votes on different project submissions. Like one project example that Elliot is working on right now, where they're just studying neurons and the neurons are connected to some interface. I'm not a expert on that yet, but it's a doable experiment, and they can do maybe 10 to 20 experiments with $1,000. And that's quite cheap per experiment. And I think this can be like, I wouldn't say game changing, but is definitely needed right now because people don't know where to go, and we can't just be in Discord on Twitter all day. Otherwise, nothing happens. So that's just one idea that we've thought about a little bit to just stimulate this tinkering. Because right now there's not enough tinkering. People don't do enough lab work or experiment on their own. It's always like in academia.
I think
I love the Frontier Tower. Sorry, go ahead, Morgan.
No, I was just going to say, I think we need the secret weapon that is holding up a lot of academia, which is philanthropy and donations from like wealthy people that just want to see stuff happen over the long term. And like, I think we need to talk some people into like putting money into this type of infrastructure, not for direct, return on investment, but for like actually being able to support DeSci and incubate it as a genuine alternative, as you said, Jake.
Yeah, I love it. So I got to visit the Frontier Tower a couple months ago. I got so excited. I got super excited for it, and it's the culture. It's the culture problem that they're solving. So like if you compare what's going on at the Frontier Tower to the experience of a typical iGEM team, for example, right? The profile, the educational profile of the participants, it's about the same. They're about, whatever, they're 22 years old, they're 25 years old, they've had some tech education, they've had some bio education. There's a sharp learning curve in terms of what they can execute. They're pushing at the limits of what's possible. The resources are comparable, right? It's the sort of whatever 10,000 scale budgets that they're working with. The difference is culture. The difference is that in the Frontier Tower is like people have a sense of belonging. They have a sense of belonging, like they're part of a community, they're part of a movement, or they're connecting with each other, and they're like there's a genuine belief that they're part of something that is going to continue and grow. And so it's still early days for a space like the Frontier Tower, but I could totally imagine it solving this cold start problem of iGEM, this walk away problem. Like, I believe that stuff that is starting at the Frontier Tower today, people are going to keep doing it. They're going to say, no, maybe I don't want to do a PhD. I'm going to grind on this for 2-3 years, longer than any iGEM team ever has. And to me, like that's transformative. That resolves one of the biggest problems that we have in terms of decentralized DIY bio.
100%.
Cool.
Send the space to Elliot to come here and talk more about Frontier Tower. Hopefully,
I'll sing his praises. We love you, Elliot.
Yeah, if everybody starts saying his name out loud, he might just show up.
It does kind of feel like that. I feel like I see him everywhere.
Jake, I'm curious, where are all of the SynBio folks hanging out these days digitally? Are they still around here on X? Have they migrated to Blue Sky, Mastodon? What's your take here?
It's a wasteland. It's a wasteland. It's a hellscape out there. It's burned to a crisp. It's devastated. I don't come here to sugarcoat it. It's pretty fucked up. I don't know.
Do you have any?
I don't have good things to say about any of the platforms, but I guess I have the most fun on Twitter still.
Any anecdotes specifically, like what exactly happened with this why was it so fragmented? Why did it get so fragmented?
Yeah, I don't know. You guys, are you guys on Blue Sky? Are you guys on Blue Sky?
Which I've tried, but I don't know how to find people. Problem again.
Yeah, I do. Yeah, I think so. So like in a lot of the mainstream academics that I know move to Blue Sky because and I understand it because there's less toxicity, there's less just bullshit, less overt racism, less I don't know what it is, less of the Twitter garbage, less of the Twitter slop is over there on Blue Sky. But on the other hand, like it's I don't know, it's a boring place. It's a boring place where sort of academics congratulate each other on how serious minded they are. And it's like, it's not a space where that, I think you can actually break through with a message or communicate meaningfully to the mainstream.
Maybe that's a white space though, for like an opportunity to go over there and do something fun.
Yeah, I think it's maybe. I mean, I don't know if there, I don't know. I don't know. Maybe I'm bitter. Maybe I'm bitter. I post memes over there and I don't get enough.
Do they have Twitter Spaces function on Blue Sky?
I don't know.
Yeah, I don't like apps that don't get me addicted. I like apps that get me addicted. It's much more fun that way.
Too good for it. I'm not too good for it.
Yeah.
I'm checking my phone at 3 a.m. I know it's bad for me. I do it anyway.
So satisfying.
But I
do. So like to me, like I do think that to like bring this back to the current state of DeSci, like to me, this division in the academic community is emblematic of a really serious cultural challenge that is happening, so basically the mainstream biotech world in particular has always been too insular, has always been sort of cloistered, has always been sort of spoiled by the fact that they only ever had to communicate to other experts and they only had their work funded by other experts. And so they adopted this culture, which like in some ways is admirable, of being very reserved, being very risk averse, being very protective of their reputations. And like in this modern attention economy world, like that just doesn't play. It just doesn't it just doesn't work. And so the fact that the academic world has sort of locked itself away in Blue Sky are like we the scientists, we the biotech people, like we are losing the headspace wars. Like we are not controlling the narrative. We are virtually outside of the mainstream conversation where all of the important decisions about the future of biotech are happening. And this is like a huge cultural problem. Maybe like this might be the most urgent issue in science right now, is like we just don't know how to engage with the public.
Well, I spoke to Ben Lamb the other day, founder of Colossal, and they did like the whole dire wolf story and the hamsters, was it, with the furry?
What was it? The furry mouse's bioweapon.
Yeah. And I asked him, like, how do you feel about this negative reception that you received? And he's like, do you actually know the statistics of like what percentage was like positive, like positively received versus negatively received? Like, if I ask you, Jake, like, what would you guess? Like, what percent of like people who like read the Guardian article or like the saw the things on social media, like what percent of those people do you think reacted negatively?
I would say the average person reacted positively, but the average person with a PhD reacted with snark.
You nailed it. He said 95% of total viewers reacted positively, and then 5% like reacted negatively. And it made me realize, and then I asked him, like, okay, these 5%, like, who are they? And they are, academics, people in our own, in our own network, in our own like ecosystem. And I don't know, that made me a little bit sad, because it is breakthrough technology. It's like the most interesting thing anybody has done in biotech in a long time. That is not, GLP-1s. That is also like quite a dry topic, but it's like everywhere, right? Everybody knows about it. And yeah, I just, got a little bit sad of like how people, interacted with that story. And I think, optimism is such an important thing for an industry to bloom.
Absolutely. In my mind, this is an opportunity. This is an opportunity for DeSci, because there is a space that is opening up between where the mainstream biotech world is and where the actual conversation is about the future of biotech. So huge missed opportunity to engage with a project like that. It's something that gets people excited. It's something that feels like the future. It's a little bit weird. People don't know how to think about it. And so you've created this gap. Like we the scientists have created this gap in the attention economy where like not only do we not play for people's attention, not only do we actively discourage people who play for people's attention because we'll say, oh no, that's not real, that's not real, like you've overstated your claims about your mouse or whatever. But we've created a space where, because we are so reliably reactionary, like you can get famous by poking the eye of mainstream institutional science on purpose, right? So like we're not it's not just that we're not playing for it, it's that we're actively driving people away. And so this is like the Jiang He Twitter account, which is like actively antagonistic to
very pretentious,
like basically trolling,
You think that's intentional? I just feel like he is just like that. Like that's just how he is.
Does it matter?
No, not at all. Not at all. Just analyzing him as an individual.
I don't know enough. I don't want to speculate. I don't want to speculate.
See, Elliot just popped up here. Elliot, feel free to request to come up if you want to say a couple of things about Frontier Tower.
So the opportunity for DeSci is that you guys have been straddling these two different worlds, these really, really awkward, hybrid, uncomfortable pairing of worlds, the world of science and research and the world of crypto and memes. And that's like a deeply unholy combination, but it's also like a very powerful combination in the sense that I don't really think that there's anyone who is positioned as well to create this kind of a third way in the discourse where you can bring the sort of like the whimsy and the energy and the sort of entertainment value that of the crypto world, the sort of like the things that gets people excited, gives people that dopamine rush, which like the world just needs that shit.
Especially if you're a PhD or postdoc, you need excitement in your life. Things can get really depressive, and that's what made me pulled me into DeSci, is because like the community in crypto, like I've never seen stronger communities of people. Like it's on on a level of like almost like
cult follow,
cult, right? And it's not always like the best outcomes that are generated when you create cults, but if you get at the rim of that, just close to cult-like behavior, but not fully, some really interesting things can start happening. I mean, there's been so many. I think it's because there's been so many crashes of so many different crypto tokens, and at those times, those people have had to really enter the Discord and talk about what's happening and share their stories, and some people manage to recover from that just because there is created group cohesion. Like people have lost thousands of dollars, even more, but they've managed to find their way back through communities. Yeah, I think science, I think biotech as a whole could benefit from learning from crypto community building.
I think that's also the main part for me is what you said, Jake, of the fun, the whimsy. Where did that all go, and why does mainstream science suck so much from that regard? Because when we were kids, or when we decided that we wanted to pursue science, when we figured out that science was even interesting as a concept, it was through I don't know if you ever got those little science kits as a kid where you made practical jokes, or you had these weird things that you had fun doing, and you didn't necessarily care about the hows and the whys, but it was you knew the outcome, you learned how these things interact, and then you might one day use that. But I don't know, I feel when I got into science, especially biotech, it was through this dopamine rush of learning new things and seeing the potential and dreaming big. I don't know if it's also the commercial landscape that has had a massive hit on that as well, but it feels rather bleak, and it feels like people have just lost imagination and risk appetite and all of these things. And a lot of that is probably to do, as you said, with the academic culture, because it's a very specific game with a very specific set of rules, and it rewards certain types of people. And those types of people aren't necessarily the fun, controversial, imaginative people. But yeah, I feel like we need to get back to that somehow.
Yeah, so part of that comes down to the sort of the cultural rigors of biopharma, and the fact that biopharma is the center of gravity for almost all of biotech, right? So like the NIH budget is 50 billion and the NSF budget is 10 billion, and that's all of the sciences, not just bio. And so like when you're out there in the biotech world, like everybody just thinks about biopharma all the time. It's the number one career path. Like if you have a PhD in biology and you don't work for biopharma right now, you might in a few years, just because that's where all of the jobs are. And so therefore, like you belong to that biopharma culture by default, even if you're not actively working on it. And so like, what's biopharma culture? Well, of course, like it's risk averse, right? Like, yeah, it's going to be risk averse because lives are on the line. It's going to be closed because you've got to protect your IP. Like these are understandable things. It's going to be cautious because the investments are so large. Like those are all like natural. And I don't exactly like, I'm not trying to hate on people in biopharma, although I do hate this. I do hate it as a culture. Like, but I get it. Like I'm hating in a nice way, I guess is what I'm saying. But this is the whole biotech world, right? And so therefore, like something like ValleyDAO, another thing that can catalyze a cultural breakthrough is if there actually was a way to make money in biotech that wasn't putting a drug in the clinic. If we could demonstrate that you can make scalable money, by engineering plants for ag, or by, engineering like an ingredient for dog food, or like a sustainable loofah for your shower, or whatever it is. Like if
I'm stealing all of these, by the way.
Like,
take notes.
And if we could get that to like, even if it was like 10% or of whatever of the market of biopharma, then there's a cultural opening where you don't necessarily have to belong to, and you can be a little bit more fun. You can get a bit looser. And so like this is another thing that I'm always looking out for in DeSci is like, can we demonstrate that there is a scalable model to make money in biotech that's not biopharma?
Amazing. Thank you so much for that, Jake. I see Elliot, welcome to the space, sir. We thought of you. We mentioned Frontier Tower. You have a lot of traction on that. And there's a lot of people here who might not know what the Frontier Tower is. And I think it's super relevant to the conversation that we're having, because you're sort of doing DeSci things without necessarily calling it DeSci. So maybe tell us a little bit about yourself if you want to, or you can just talk about Frontier Tower. Up to you. Both are equal. Both are equally interesting.
I love seeing a lot of like familiar faces on here, and this is I think my first Twitter Spaces or X or whatever the hell we call it now. Yeah, a bit of background on me. I did biomanufacturing for a while, and then shifted over to a venture studio, and helped mostly in like ag and biotech, climate, things like that. And then more recently, I was really frustrated with how things got built in biotech. I think part of the challenge that Jake laid out really, really clearly is the fact that it's hard to make money. And so that's why most people resort to pharma. But pharma, you don't make money by curing people, which is really frustrating. Like there was something going around JPM, which is the JP Morgan Chase, this bank that finances most of the pharma companies, where I think like a Goldman Sachs banker was talking about keeping people sick for as long as possible so you can milk them for money. And that's why people hate pharma, is that a combination of pharma and insurance companies end up keeping people really sick so that you can take their money. Those are the worst companies. There's some companies that are doing okay and like trying to cure people actually. And I think overall, like when you look at the people involved in pharma, the motivations are relatively pure. Like they really just want to help people. But curing people doesn't make money. And so that's a sad bit, is that we have this culture in pharma development where you keep on coming back to the same people for this medicine so that you keep on paying them. And there's some instances where you can get cured for something, but it costs hundreds of thousands, if not millions of dollars to get the cure. And in fact, companies are shifting away from gene therapy and cell therapy style cures, particularly because it's not something you can make money, which is really frustrating. So I think when you look at the DeSci ecosystem, it's really exciting because you have this sort of like grassroots push towards things that actually solve problems. And overall, I think there are ways, especially at the edge cases, and the weirder that you get, the stranger and more fun that you end up getting, that you can make money. I just chatted with a guy who makes $50,000 pop helping clone pets. So like you go really, really weird and you can start making money. And I see Josie in the audience too, which would be cool to invite Josie up because Josie's made money in a bunch of weird ways on the edge cases and the fringes of biotech. Yeah, Frontier Tower and kind of the biopunk community is this motivation to move towards this grassroots counterculture, this idea of not having to accept VC money, like doing real things for real people and trying to follow this punk ethos of DIY or die, this kind of mentality of like rebelling against hierarchies and enabling communities to kind of like support themselves. So we have a pretty nice lab space. We're in the middle of build out on our BSL2 space here in downtown San Francisco. And then I've also been pinged by a bunch of other folks around the world to set up new lab spaces. And so a network of labs all over the world that are super cheap. Our main kind of frustration in getting started is a third of the money that you raise in terms of venture goes either into personal rent or into laboratory rent. And so you spend like $2,500 or more on a bench space just to even get started. You have no opportunity to develop a proof of concept. And so part of the point of Biopunk Lab is to make it so that you spend $350 on lab space. And you have this co-working lab that makes it stupid easy to get set up. It's all community run and community managed. Like I tell people it's kind of like Frontier Airlines or Ryanair, where it'll get you to where you're going, but it's no frills. It's not fancy or anything like that. If you want extra, you got to pay for extra, but it does do the job. And we have a bunch of teams here actually getting started. We just had a lab automation team raise like $6 million and get set up in their own space. And so, yeah, it's kind of a means of starting from the grassroots and focusing on companies and individuals that are developing proof of concept that want to sell real things to real people. I hope that summarizes it a little bit.
Amazing. Yes, it does. And like, what is the, like if I have an idea and I'm based in SF and I want to join this, how does it work? I just show up?
Yeah, kind of more or less. I mean, we have memberships through frontiertower.io is like a co-working membership. And then you have add-ons to get access to the lab space. You apply with a particular project in mind. Everybody in the lab space has to have a project going on. We have about 60 members of the lab right now. We got started in April. And then from there, you can kind of upgrade to BSL2 space. And then beyond that, I mean, we do events and classes and other things like that to get people involved. We do more or less like a monthly hackathon of some sort. So you can win prizes, get rewards. We'll do like an annual unconference where I saw a lot of you at the unconference. Jake ended up speaking at the unconference. Josie came on by and gave like a fireside talk, which was really cool. And then open days are like Fridays. So you can pop on by for like an open co-work day and check out the lab space and everything. But I'm kind of visiting a couple of different cities around the world to kind of scout out our next location. And there's a few communities that are really interested in kind of spinning up. And it really just kind of depends on the density of people that are willing to play in biology. The analogy I kind of give is that there's nowhere in academia or industry that you can kind of create 4-leaf clovers just so like just because you want to like flood the luck market with 4-leaf clovers. And like, where do you go in the world to go about doing that right now?
And Elliot, what are some exciting projects happening right now that people are working on?
Yeah, we got a team working on open source MEAs that actually just raised by coming up with like a meme coin through Believe. They're called the Electrodes team. We have somebody who's doing stem cell differentiation to create mature cell lines that actually model and mimic pre-existing cells in the body, and he's working on getting liver cells, hepatocytes, spun up right now. We also have somebody doing like lipid nanoparticle drug delivery systems. We have somebody else who's doing like plant protein things, just a bunch of huge variety of different projects. It doesn't really matter the type of project. All the equipment is shared, and it's pretty fun to see the overlap of different things. We also have people who are doing like lab robots and like meta science things, so like AR glasses for laboratory management. It's cool seeing also the pace of things too. There's a bunch of folks who are just like working really hard every single day.
So cool. And are you planning to open one in Europe anytime soon?
So I'll actually be in Europe for Biofabricate. I'm trying to kind of get everything settled for this rave, this kind of after party. I really enjoy the practice of throwing parties to get people together. So be on the lookout for some sort of party in London. I'm going to chat a little bit with Life Labs London, which is a DIY biospace there, to see whether or not there's opportunity to set up another kind of space in London. And then I'm going to be in New York as well. So checking out whether or not there's overflow space for GenSpace, because I know they're a little tight on space. But yeah, there have been some other cities that have been called out too, places like Singapore, where I spent some time. And let's see, Switzerland, somewhere in Switzerland, potentially. Yeah, I had been chatting a little bit with the folks in Prospera in Honduras, but like as always with many of these different places, you got to put money where your mouth is. So as long as there's some support from the community and there's interest and there's demand, then there's a reason to put together a lab space there. But yeah, the overall idea is that once you have membership as a biopunk, you can gain access to any of the labs all over the world. But I guess the kind of kicker is, and what people tend to ask me is what kind of like metrics or value or economic value comes from these more grassroots, upstart, low cost lab spaces. And I tend to point people in the direction of like Mammoth Biosciences, which started out of BioCurious, or OpenTrons, which started out of GenSpace. And what's really frustrating to me is we still have this like crazy credentialism in biotech. In order to kind of get any sort of resources for a project, you need a PhD. In order to like actively go about setting up, there's this huge tax on just renting space. And yeah, it's all this like rent seeking behavior from VC as well as from like equipment manufacturers or reagent manufacturers.
Definitely. It's sad to see.
Albert and Morgan, can I do a little wrap up?
Plug time.
Okay. Go for it.
Okay. So I've been interested in DeSci and DIY bio for 15 or 20 years. And I think this is the most exciting moment that I've seen in the course of my career. So we've got pretty steady progress in terms of the education layer, getting people informed and capable of what they need to do to engineer biology. We've had steady progress in the execution layer. So we have, because of lab automation and because of other service offerings and because of spaces like Elliot's that are lowering the costs of being able to execute on engineering biology. We're getting better on the trust layer. So building a system that can integrate the sort of rigor of science with the enthusiasm and the whimsy of the crypto world. But the thing that is the most exciting to me, the thing that seems to be changing now faster than I've ever seen, is the changes in the culture layer. So which is to say that people are seeing DeSci and DIY bio as something that they belong to, as a community that they belong to, as something that they can stay a part of for as long as it takes to build something with biology and to build a career in biology. And that expresses a different set of values, a new set of values that have always prevailed in biopharma, and that are therefore going to drive a new set of technologies.
The community aspect is, when I look at our Discord and the work that we do, and we interact with so many people, and people join in at like different stages of ValleyDAO. What makes me really, really happy is seeing continuing to see like the same people that were around from like the first 2 weeks of initiating ValleyDAO. And some of these people, like I've gotten to know like really well. I consider them like friends. And it's such a cool thing to have in a professional context as well. And I think that's what has been missing in the culture for a very long time. Thanks to the digital space that we can create these connections, where previously maybe you had to be located in Boston or SF to feel such a culture.
I love it. You're part of my culture. I'm so proud. I'm so proud to be a part of this.
I'm very happy to hear that. Tom, should we any things from your side?
Yes. Well, first of all, guys, I'm in the audience. If anyone wants to ask any questions, Jake, or Albert, I think Morgan. Oh, Morgan's back here. If you've got any questions and you want to ask our speakers, literally anything, feel free to request to speak and I'll get you on stage. In the meantime, I just wanted to take a moment and actually, I just want to say thank you so much to Jake, to Albert, to Elliot, to Morgan, because the whole space, this conversation has been so thought-provoking. I had so many different ideas. I've taken some notes and we're obviously going to create some additional content around what you guys been saying. But one of the key things that I really wanted to highlight is that DeSci and science and biotech and climate, especially climate biotech, can be so complicated to people, to just average Joe, to understand the concept of. That's why it's so much easier for meme coins, for even AI, when it's a technology, to have this kind of appeal to normal folks, right? Whereas with science, it's much more complicated. There's a lot of completely new concepts and trends that we're trying to explain to people. Sometimes it's way too complicated, and to find this kind of the right narrative and the way of explaining it to people, it can be sometimes difficult. But this conversation that we've been having here so far today, it's been eye-opening. It's been super accessible to a lot of people, I believe. I wanted to ask you guys if you've got any final thoughts before we wrap things up, unless there's anyone from the audience that wants to join us quickly. Jake?
I have had a blast. I have got to drop, unfortunately, but I'm very happy to continue this over DMs.
Jake, thank you so much.
Bye, everybody.
One final thing from my side is that me and Elliot are currently ideating sort of like perhaps let's call it like a sub-community of like the biopunk movement and the ValleyDAO community, where we want to create some sort of opportunity for people to donate/subscribe on a monthly basis, everything from as little as like $1 per month. And all of this would go into a pool of capital that we can distribute to different DIY community projects, such as those that are taking place at, for example, like the Frontier Tower, but they can also take place essentially anywhere in the world where there is, capable people that can, that want to do biological experimentation, no strings attached, nothing of that. It's let's call them nano grants, because they're not, I wouldn't call them a micro grant. A micro grant is like 5 to 10K, but this is something closer to like 1K to 2K. And yeah, so if people are interested in something like this, want to be part of this sub community, want to become a subscriber, for example, just hit us up and we can get the conversation started on that.
Yeah, the point is that it's the community helping the community. And so there are some people who are active in a pre-existing role in biotech or pharma who just want to support new ideas in the community. And right now, there's not as many accessible pools of capital for just little proof of concept experiments. And so especially for younger folks who really want to get involved, engage, and test something out, this is going to be for them. So if you're really interested in helping support those people, please let us know.
100%. Thank you so much. I'm pretty sure that we'll need to invite Elliot and Jake again to the Proof of DeSci podcast for part 2, because there's still a lot of questions that we can discuss and a lot of topics that we should talk about. But I believe that, guys, this is it. That wraps up this episode of Proof of DeSci with Jake Wintermute, with Elliot Roth, with Albert Morgan from ValleyDAO. Thank you so much for joining us. Guys in the audience, make sure to go and follow Elliot, Jake, Albert Morgan, and of course, ValleyDAO. It's clear that the future of DeSci won't be just built in labs, but in actually communities, culture, and conversations exactly like this one. If you enjoyed today's episode, make sure to subscribe to our podcast on all the major streaming platforms. Share and leave a comment here under this Twitter Spaces. And if you want to get involved in building the future of DeSci, come join us at ValleyDAO on Discord, Twitter, Telegram, or wherever you hang out online. I'm pretty sure we've got profiles literally everywhere. And once again, thank you so much for joining us. Thank you for listening. And we'll see you next time on Proof of DeSci.